Forgive me if you hear, like, the airflow from my speaking. I'm recording this on, like, a tablet microphone, so, yeah, I can't really put a pop filter in front of that. I mean, I could, but that would mean holding two things at once for, like, 2 hours. And I'm just too damn lazy for that, so yeah, no thank you. I'm done with Flat Earth for the time being. I've just really nothing else for me to do. I've covered it all over, like, in my comics and last three videos. I might do more in the future, I don't know. But for now, I'll cover my favorite topic. I specialize in neutron stars. I just love researching them. It's my passion. And hopefully I'll get to make discoveries about them later on in life. Another word for them is pulsars. You know, those things in Elite Dangerous that are absolutely terrifying and can cut your travel time in half, or even more, if you're smart enough. And that, my friends, are the words of a fool who made this script before actually encountering a neutron star in Elite, which was less than enjoyable when piloting a hauler. These are amazing astral bodies, and it's a shame that they aren't very well known, but that lets me have my own little niche. Now, Kurzgesagt already did a video on these, but I researched these in 2016, which I was in grade 7 at the time. I'll be using the speech I made that year with modifications and including some new information, but I won't use much of what Kurzgesagt has already covered. Look, I ran out of, like, quote-unquote funny sound effects to use for the opening, so I just went to the Price is Right failure horns. I'm running out of creativity for these intros. In the 1960s, two scientists discovered powerful and intense radio wave radiation with incredible temperature and gravity in the Crab Nebula. Having suspected it came from the currently hypothetical neutron stars, they looked further into it. But who hypothesized these in the first place? Fritz Zwicky and Walter Baade of the California Institute of Technology predicted their existence in 1934, and that was just after the Great Depression. I'm also pretty sure I fucked up those names. After decades of study, they were proven to exist in 2013. To begin, neutron stars are the most small stars and third most dense objects in the known universe, black holes in second, and my skull at first. Neutron stars are the result of a supernova, the explosion of a massive star along with a gravitational collapse. What's gravitational collapse, you ask? A gravitational collapse is when an astral body has such powerful gravity that it collapses in on itself. Also, neutron stars shouldn't be confused with white dwarfs or even protostars. I don't know how people do that, but they do. Neutron stars are as large as cities, but more massive than the sun, about 1.4 times that of the sun. As previously stated, they are extremely dense, so dense that a teaspoon of the material would weigh 10 million imperial tons on Earth. Now that's around 10,160,047 metric tons. Within a neutron star, past the iron surface, atoms are packed so tightly together that protons and electrons cannot exist separately. They merge and become neutrons during the gravitational collapse, hence the name. Also, their escape velocity is 40% the speed of light, so 119,917 kilometers a second, or 74,513 meters a second. Miles a second, not meters, is needed to escape the gravitational pull. Furthermore, these boys are so small that they are 10 billion times fainter in space than you can see with your eyes. Too much for even the Hubble Space Telescope to see. So then, how do we know they exist? The pulsars of radio waves. What better explanation in space for that than neutron stars? They are visible through their radiation on rapid That is not typed correctly. They are visible through their radiation and their rapid rotation. And recently, scientists found ripples in space-time caused by two neutron stars colliding. Now that's fucking metal. Finally, not really, some extra information on these terrifying beasts of space. They exert a lot of gravity for their size, 10 kilometers in radius, which is around 6¼ miles. If you stood on one, you'd experience gravity 200 billion times that of Earth. Which I doubt would be a nice feeling. I mean, somebody weighing 140 pounds on Earth would weigh around 2,800,000,000,000 pounds on a neutron star. Imagine trying to lose weight then. What about the Sun? Will that become a neutron star? No. It's not massive or large enough. The types of stars that become neutron stars are 1.4 times as massive as the Sun, which is 19 to 29 solar masses. If it's 5 times as massive, the supernova will result in a black hole instead. Now, what will the Sun become after it dies? A white dwarf. Now back to neutron stars. They spin at 4.77% the speed of light, 716 rotations in a second, which is 14,320 kilometers a second. If an asteroid was caught in the force and gravity of a neutron star, it would orbit rapidly until it crashes into it or is ripped apart like a planet to a black hole. The gravity of a neutron star should crush a human like an anvil falling on a tin can. We have sent somebody out to a neutron star, so let's take the latest picture from Jimmy's spacecraft.
Shit.
So, what else is there to learn about neutron stars? Much more. Let's go over some fun facts about them.
Ow!
Oh, what?
What's up, fam?
Okay, how did you get in here? Hey, that's my script.
This is a nice script. Well, hold on. You're organized?
Yes, but how did you even get in here?
I'm gonna take over your video now, bitch.
Do you even know what half of this even means?
Ha! No.
Oh, great.
If it had the mass of Earth, how big would it be? About 4 baseball fields. They have a density of around 5 times 10 to the 17 kilograms a meter to the -3. So if Earth had that density, it would be around roughly 450 feet in radius. A little bite-sized Earth, if you will. You know how black holes look, right? If not, here. Notice how it looks like it has 2 rings. The one in front is how the ring should look. But what about the rest? That's light being pushed from the behind it. That's light being pushed from behind it to around it. Notice how the stars behind are stretched and warped? They're all light being pushed from behind. It bends space-time. But what does that have to do with neutron stars? Neutron stars do a bit of that too. But I mean, you don't really see the effect because it's minor and the entire thing is white. He said he wouldn't say much of what Kurg's gesagt.
That's not how that's supposed to be pronounced.
Covered. But this was too interesting to leave out. This leads to another topic. What color are neutron stars and why? They're white, so they're extremely hot, so they would appear white to us. But you shouldn't really see them either. They emit X-ray radiation wavelengths, which are past the infrared scale.
Yeah, I did write that in the script. Remember when I said that they're visible, but they're too faint for the Hubble Space Telescope to see? Yeah. I think what I was trying to say in that bit in the script was that you shouldn't be able to see a color? I don't really know.
I guess you want to have color, here? How hot are neutron stars anyway? Around 5 times as hot as lightning, which is 600,000 Kelvin. The sun is 0.963% as hot, and lightning is 30,000 Kelvin, which the sun is 19.26% as hot. But why are they so hot? Well, they're the core of a star, and stars get very hot near the core. Why don't they cool down? They do, but extremely slowly. Heat energy has nowhere to go except for electromagnetic radiation and the average photon. This means that it would take around 10 to 100,000 years to drop to absolute zero, 0 Kelvin, or about negative 273.2 Celsius, which is about negative 459.7 Fahrenheit. You know how every image of a neutron star has a cone shooting of its poles? Pulsars have extremely powerful magnetic fields that shoot jets of particles out along the magnetic poles. So why do so many black hole interpretations have the fucking cones? Well, apparently beams of ionized matter are shot out of a quasar
That's not how that's supposed to be pronounced.
at nearly the speed of light. Quasar is another name for supermassive black holes. I only know this because I read off the script. I'm not gonna remember any of this info.
Okay, I'm gonna take back my video now. Thanks for that. I hope you realize you're gonna have to pay for the property damage.
Bye!
My other window!
Only name is I think you broke something.
That's all there is to cover. Now you can go and impress all your friends. That's right, the whole zero that you have, with your immense knowledge of neutron stars and knowing that you wasted all that time researching it for half of it not to amount to anything. So, you made it to the end of the video. That's surprising. Why don't you go ahead and check out Boyo's channel? He's a good friend of mine, and his content is hilarious by my standards. So why not go pay him a visit? Through his window.